Good morning, everybody. So today we're going to be continuing on with our unit on rational expressions and equations. Today we're going to step it up just a notch. We're going to be multiplying and dividing them. So don't be scared. We're going to be using basically the same procedures that we would for multiplying rational numbers, right? And when you're multiplying rational numbers, all you're doing is, if you have two fractions here, you multiply the numerator times the numerator. So 5 times 4 is 20. And you multiply the denominator times the denominator. So 8 times 15 is, let's take out our calculator. Eight times 15 is 120. And then you can simplify. So then you reduce the numerator and denominator. So 20 over 160 is 1/6. Okay. So that's all. But you can simplify this process a little bit. If you reduce by alike factors and then multiply, it can sometimes be easier. So we can also think of 5 over 8 as 5 over, instead of 8, let's reduce it to 4 times 2. So this is going to look a little bit like what we were doing with radical expressions. And some of you may like this form. Times, let's go 4 times 5 times 3. And what's going to happen here when you're multiplying radical expressions, again, it's numerator times numerator, right? So on the top, you're going to have 5 times 4. And on the bottom, you're going to have 4 times 2 times 5 times 3. And you might be going, you know what, Mr. Emond, this doesn't look much easier. But remember, when you have alike terms, when everything on the numerator is being multiplied and everything on the denominator is being multiplied, when you have alike terms, you can cancel them out. There you go. And now you can see why this method is sometimes easier. Because now what are you left with? On the top, just a 1. There's an invisible 1 there, right? It's not 0. 1 times this, right? So this is just a 1, and then 2 times 3 is 6. And we get the same answer, it's just in a different form, right? This method, you're going to realize very soon why it can be a little bit easier in the long run. So let's get started. With rational expressions, we're always going to want to factor out each numerator and denominator first. That's your first step. Simplify by factoring. Then we can cross out or divide alike factors, just like we did in the previous example. And don't forget your non-permissible values. Actually, let's start with our non-permissible values here. So I'm just going to move this up, change my color. And I'm going to start with my non-permissible values. So where are the non-permissibles going to come from? Here and here, right? So we have a squared minus 9 cannot equal 0, which means a squared cannot equal, okay, sorry, my cat is walking all over the computer. A squared cannot equal 9. Which means a cannot equal plus or minus the square root of 9. So a cannot equal plus or minus 3. So there's my first non-permissible value. My second one is a squared minus 4a cannot equal, actually we're going to factor that first. Yeah, let's factor this one first. So you have, let's factor it all. A minus 4, a plus 3. And then down here is going to be a plus 3, a minus 3. And now you can see where we got the a equals plus or minus 3, right? It's from these two here. Multiplied by, this one's going to be a minus 3, a minus 1, and this is going to be a times a minus 4. So the reason I wanted to factor it out for first is to get to this, and now I can see quite clearly a cannot equal 0 and a cannot equal 4. So you can factor first or not for the non-permissibles. It's probably easier to just factor first, especially when you're dealing with things like this. You hopefully see why I kind of hesitated to keep going with a squared minus 4a cannot equal 0, because then I would have had to factor and split it up anyways. But here we go. Let's cancel out like terms, because we know that these numerators are going to multiply together and these denominators are going to multiply together, and anything that's similar on the top and the bottom we can cancel out. So those are similar on the top and bottom because these lines will eventually connect and this gap will close, right? And the reason why this is happening is because numerators multiply by numerators and denominators multiply by denominators. So I don't really have to do that step. I can just start canceling out like terms. So I have a plus 3, a plus 3, a minus 3, a minus 3, and I'm left with my final answer here. And my final answer, all that's left on the numerator is a minus 1 right there. And all that's left on my denominator is this a here. So that's it. Don't make the mistake of simplifying out to get this and then doing your non-permissible values. Do your non-permissible values first. Because if you had gone to this point and then did the non-permissible values, the only non-permissible value you would have found is a cannot equal 0. But that's not the only one that exists. A cannot equal 0, a cannot equal 4, and a cannot equal plus or minus 3. So there's actually 4 non-permissibles, not 1. So be careful about that. Let's do 2 examples. I'll do 2 examples, and then you have some practice to do right after me. So we're going to multiply our numerators and our denominators. There's not too much simplifying we can do here. So we have 4x squared y squared times 3, and then I'm just going to combine these, x squared y, and then this one I'm actually going to turn into 4 times 2. This 8 I turned into 4 times 2. And I bet you, for those of you that are following along, you know why I did that. It's because I'm going to want to cancel things out, right? Ooh, and I kind of should have a division sign there, hey? Okay. Now let's cancel things out. I have an x squared on the top and an x squared on the bottom. I have 2 y's on top and 1 y at the bottom, so I can only cancel out one of the y's. So I'm just going to do that by getting rid of the exponent here and this, so I just have the y left. And there's a 4 here and a 4 there. And now hopefully you see why I split that 8 up. What am I left with on top? Just a y. And on the bottom, I have 3 times 2, which is 6. So this is 1y over 6, or 1/6 y. And you see this simplified quite a bit, right? So it's really useful to know how to work with rational expressions exactly for this reason. You can see how useful this is going to be next year in your calculus classes. Let's do the same thing over here. So this time I'm going to do a different first step. I'm going to factor first. So this is going to be y squared minus 9 is going to be factored into y plus 3, y minus 3. This r cubed minus r, we're just going to remove the r first and have r squared minus 1. Let's do that one now. R squared minus r, it's going to be the same step, right? Remove an r and you're going to be left with r minus 1. And we can't really do anything to this denominator here. So we're not quite done. I can factor this one step more. Can I? Yeah, I can. So this is going to be y plus 3. I'm not going to change my top. Y minus 3 over r times r plus 1, r minus 1. That's this step here. I factored that step. Multiplied by r times r minus 1 and y plus 3. And now that we're fully factored out, we can start canceling, right? And I'm just going to put this in parentheses. So I have y plus 3, r minus 1, r minus 1, r and r, and I'm not left with very much left. So again, this process has saved me a ton of work in the future. I have y minus 3 over r plus 1. And just think how much simpler this is to graph and work with. This is equivalent to what we started with. Y squared minus 9 over r cubed minus r times r squared minus r over y plus 3. These two things are equivalent. They're the same. Who in their right mind would rather this over this? So simplifying rational expressions is such an essential skill. Let's have you give this a shot. So try it out. There's two problems for you here. One is significantly easier than the other one. This one you're just multiplying rational numbers. This one you're multiplying rational expressions. On YouTube, pause the video here, work it out, and come back for the solutions. See you soon. Okay, for those of you on YouTube, welcome back. We've worked out the solutions for you here. So we just actually split things up into 3 steps, especially for this second one here. First step, factor. Second step, find your non-permissible values. Third step, simplify. And here's what we did. So for this 5 over 9, we actually turned it into 5 over 3 times 3. And for this 3 over 10, we changed it into 3 over 5 times 2. And this helped us get rid of like terms, canceling out 5s and 3s, leaving us with only a 1 on the top because everything canceled out, and a 3 times 2 on the bottom, so 1/6. On the right-hand side here, we combined everything into kind of one step. So we had an x plus 1 in the numerators and an x minus 2 in the numerator, and we just multiplied them together because you can't really simplify that out anymore. This bottom one here, we factored x squared minus 5x plus 6, we factored into x minus 3 times x minus 2. The bottom right one here, we factored into x plus 4 times x plus 1. And at this point, we were able to cancel out some like terms. This x plus 1 is going to disappear, and this x minus 2 is going to disappear. So all that's left on the top is that invisible 1, right? The same invisible 1 that existed here. And x minus 3 and x plus 4. And there's your answers. All right. Let's go to dividing rational expressions now. Dividing rational expressions, you're going to be doing something that hopefully you remember called multiplying by the reciprocal, right? So let's practice this over here. We have 5 over 3 divided by 1 over 6. How would we solve for this without a calculator? I would change it into 5 over 3 times 6 over 1. So this gets flipped and your division sign turns into a multiplication sign. That's the process. Multiply by the reciprocal. So 5/3 times 6 over 1. This we could simplify into 5 times 6 is 3 times 2. And then 3 times 1 there. And we don't really need a calculator anymore. The less we can use calculators, the better, right? And now this is 5 times 2, which is 10, over 1, which is 10. So that's multiplying by the reciprocal. Hopefully you guys remember that strategy. We're going to use that now with rational expressions. Let's try this one out. So this looks complicated. It looks scary. There's a division sign here. Oh my God, what do? You just multiply by the reciprocal, right? So what was step one? Step one was factor. Let's factor. So this x squared minus 4, we're going to turn into x plus 2, x minus 2. And if you're not quite as quick at factoring these out in your head as I am, you'll get there, I promise you. Like, we did that unit on factoring, and eventually you're just going to be able to look at these things and see them, because the patterns, they become very repetitive, right? Whenever I see no missing term, whenever I see a missing term, like there's an x squared and just a number, that means that middle term had to have canceled out. So there's a positive something and a negative something, right? And you divide this 4 by 2 in half, and you make one of them positive, one of them negative. That's it, right? Let's factor out this one here. So we have x squared minus 4x, and again, we have like terms here, right? So we're going to factor out those like terms. X times x minus 4. Let's do this one now. X squared plus x minus 6. So this one is going to have a middle term, so I need to have two numbers that multiply together that add up to this, and that is negative 3 plus 2. Negative 3 times 2 is negative 6, and negative 3 plus 2 is oh wait. Sorry. There you go. So again, 3 times negative 2 is negative 6, and 3 minus 2 is 1. So we want to have x plus 3 and x minus 2. Let's do the bottom right one now. Same strategy here. We have a middle term. It has to be positive 1. What two numbers multiply to 20 and add up to 1? That's 5 and 4, right? Positive 5 and negative 4. 5 times negative 4 is negative 20, and 5 minus 4 is 1. So this is going to be x plus 5 and x minus 4. And I'm just trying to show you guys how I'm doing these in my head so quickly, and it's just, I'm very used to factoring at this point, right? And you will get there too, especially if you keep up those skills that we practiced earlier with the methods for factoring. So now we know that these two are going to combine, and these two are going to combine. I can put this in parentheses, that's no problem. The next step was find your non-permissible values, right? So let's find our non-permissible values. Be careful. How many of my students mess up non-permissible values for dividing rational expressions? I would say 70% of them, if they don't remember this simple thing. And so let's do this. We know, we went to this step, right? Where are non-permissible values going to come from? You would tell me here, 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 and here. So let's do them. X cannot equal 0. X cannot equal 4. X cannot equal negative 5. X cannot equal 4. And you're certainly right. These 4 are non-permissible values. But we're not done. Why are we not done? Let's look at the original. Where did this x plus 5 and x minus 4 come from? Or sorry, this should still be a division sign, right? That came from this one, right? As soon as we multiply it, what's going to happen? This gets flipped, right? So let's flip it. As soon as we multiply it, it's going to get flipped. So you have x plus 2 times x minus 2 over x times x minus 4. So this one stays the same, but now we're going to change it from division to multiplication. And we're going to multiply by the reciprocal. So our x plus 5 is going to come on top with the x minus 4. And our x plus 3 is going to come on the bottom with our x minus 2. Now I want you to take another look at your non-permissible values, and you'll see where kids make the mistake. Is where did our non-permissible values come from now? They came from here, 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 and here. I want you to ask yourself, can this be equal to 0? No. If this parentheses is equal to 0, then you're going to end up with 0 times 0 times 0 times 0 in the end, right? And can you divide your final thing by 0? No. So that means that this is also a non-permissible value, and so is this. So we also have x cannot equal negative 3, and x cannot equal 2. We have a whole slew of non-permissible values. And this is where most students forget this. Your non-permissible values when you're dividing is going to come from this term, and this term. All three of these sections give you non-permissible values because of that multiplying by the reciprocal, right? This happens to be both a numerator and a denominator, and this happens to be both a numerator and a denominator. It depends on whether it's in division form or multiplication form. So all three sections become non-permissible values. Hopefully that clears that up. Please don't make this mistake on your assessments. You have been warned. Many students, that is their downfall. Let's cancel out like terms. So now that we've multiplied by the reciprocal, we can start getting rid of things, right? We have an x minus 2 on the top and x minus 2 on the bottom, an x minus 4 on the bottom and x minus 4 on the top. Can we cancel anything else out? Doesn't look like it. So now we're kind of stuck. What are we left with? X plus 2 on top, x plus 5 on top, x on the bottom, x plus 3 on the bottom. This is not quite as neat and tidy as the answers that we've been getting, but this is as good as it's gonna get for this problem. There we go, we're done. We found all of our non-permissible values and simplified as far as we can simplify. I'm gonna do one more, okay, and then it's gonna be your turn. I just wanna make sure you guys are good on this. So I'm going to start up here. That's supposed to be a star. That didn't work out very well. I'm going to try making another star. There we go. That's not very much better either, but it's okay. I'm going to start by factoring out this numerator. This is going to be m minus 7, m plus 1. I'm going to do this denominator now. We're going to have m plus 7, m minus 7. I'm going to keep it as division for now, but I'm still going to factor. This is going to be m plus, when I say this, I'm talking about this numerator, m plus 7, m plus 1. And we're going to divide that by here. We're going to factor out an m, and it's going to be m plus 7. Now we're going to start with our non-permissible value list. And remember, it's not done yet, right? So I'm just going to say non-permissible values, NPVs. And so far we have m cannot equal 7. Wow, what happened? So far we have m cannot equal 7, m cannot equal negative 7, m cannot equal 0, and m cannot equal negative 7 again. I don't need to repeat myself though, right? I have an m cannot equal -7 here and here. They double up. I already know that m can't equal -7, so I'm just going to get rid of this one. Okay? Let's multiply by the reciprocal. So your left side stays the same. m minus 7, m plus 1, over m plus 7, m minus 7. Now we're going to multiply, so changing it to multiply and flip it. M on the top with m plus 7 and m plus 7 on the bottom with m plus 1. Now we have two new non-permissible values that arrived in our denominator. We have m cannot equal -7, which is already there, and m cannot equal -1, which was not there, right? So again, I'm going to erase this one because we don't need it. And I'm just going to scooch that one up. And there's my non-permissible values. So that's part of my answer. At this point, what's the next step? Simplify, right? So now that we're multiplying and the numerators will combine and the denominators will combine, we can start canceling out like terms. So we have an m minus 7 and an m minus 7. We have an m plus 1 and an m plus 1. And an m plus 7 and an m plus 7. That simplified out very well. What are we left with? Just an m on the top and an m plus 7 on the bottom. And there's my answer. So my answer comes in two parts, right? I have my simplified answer and my non-permissible values. Now it's your turn. So for those of you on YouTube, now's when you pause the video, give these two a shot and come back when you're done. Okay, for those of you on YouTube, welcome back. We have the solutions worked out for you. Let's go through them. So on the left-hand side here, we started off by factoring, and there wasn't too much factoring to do. The only thing we did was factor out a 4 from here. So you have 4 times x minus 3. And then we multiplied by the reciprocal. So we just swapped them around, and then we started canceling out. So x minus 3 from the top and the bottom, and then you combine them. So 4 times x plus 3 over x. And your NPVs are x cannot equal 3 from these two. And then once you swap them, you have x cannot equal 0 from there. Let's go to the other side. We factored out this numerator here and this denominator here. And then we determined some of our non-permissibles. X cannot equal 5, x cannot equal -4. This one's the same. So that's where these first two came from. Then you multiply by the reciprocal. So you multiply and you swap. And we end up with this. And now we can cancel out like terms. So x minus 5, x minus 5, x plus 4, x plus 4. All you're left with is x plus 3 over x minus 7. There we go. Let's do the last one for the day. Again, it's your turn. We're multiplying, we're dividing, we're doing multiple steps here. Does it matter which one you do first? No. No. In fact, I would do them all at once. Multiply by the reciprocal, then just multiply them all together. Give it a shot. Come back when you think you have a solution. And if you can't figure it out, don't worry, we'll have the solution ready for you as soon as you return. See you. Welcome back. Let's go through the solution. So we started off by factoring the 3 out of the top here. and factoring this one into 3x plus 4 and x minus 3. Then we multiplied by the reciprocal. So we multiplied and swapped these two. And this one gets left the same, right? While we did factor out a 2 here. So we factored out a 2 here. Now we can cancel things out. So we have an x plus 4 on the top and the bottom. We have a 3x plus 4 on the top and the bottom, and an x minus 3 on the top and the bottom. All you're left with is 3 times 2 on the top, which is 6, and 12 on the bottom. 6 over 12 can get simplified down into 1/2. And your NPVs, your non-permissible values, come from this. So x cannot equal -4/3. This, so x cannot equal 3. This one's the same, and x cannot equal -4. When you swap and flip this one, this 12 doesn't become a non-permissible value. It's really nothing. So there's your non-permissible values. That's it for today. Thanks for joining us, and see you next time. Bye. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here you will find the next video in this unit. Keep learning, everybody. Take care.